All right, so in question 2, what we're doing is we have a saturated solution, so we can go right to equilibrium on these. And so again, you're talking about the KSP of lead fluoride. So what you're doing is you're looking at lead fluoride solid that's breaking into lead and 2 fluorides, both of which are aqueous here. And then your KSP for this is going to be equal to, running out of room here, make that a little smaller here, change my, there. So then your KSP is going to be equal to the lead ion times the fluoride ion squared that's there. And I told you what it was. I told you that it was 4 times 10 to the negative 8th. So this is going to be 4 times 10, 4 times 10 to the negative 8th. And it wants to know what this number here is. It wants to know what that is. That's your X, because it wants to know the moles of the sodium fluoride. Now you might say to yourself, there is no sodium in this, and I get it. But when you put sodium fluoride in something, it's going to break into the sodium and the fluoride. We're just going to ignore the sodium, and the fluoride is there. So all it's asking for is the fluoride. And then it wants the lead to be 1 times 10 to the negative 6th. So this is 1 times 10 to the negative 6th. So they're giving you everything. Again, they said saturated. So you got I, C, and E is your saturated. That's terminology from our lecture that we talked about. So really, this is just a plug and chug. So this is 4 times 10 to the negative 8th divided by 1 times 10 to the negative 6th that's there, and then you just got to take the square root of that. So you get 0.2. So 0.2 is your answer there, 0.2 moles. Because it's a liter, right? If it had been some other number, then you would have to take the volume into account. But because this is a 1 liter situation, they're keeping it easy for you. It's just going to be 0.2 moles.